Do you believe in magic or it's science? Hi, I'm Jenny and there's a trick that I want to show you. Impossible? I can make water stay in the glass every minute upside down. Impossible? Well, let me show you.
I'm gonna pour the water into the jar, flip it upside down and slowly take away the card. The water stay in the glass. So what's the secret behind this? Well, it's surface tension. Good trick. Surface tension is a force which causes a layer of liquid to behave like an elastic sheet or a membrane. Cohesion between water molecules creates a strong band while adhesion attracts other molecules to the mesh, ultimately leading to the surface tension. With the vacuum in the tap at atmospheric pressure from below, the water stays in the glass. Amazing, right? Surface tension, in which we look at how do intermolecular forces affect the surface of a liquid. So what's going on at the surface of a liquid? Let's take a look at the shrinking to the nanoscale. So here we are looking at the individual molecules in a liquid, and let's say that each blue circle represents a molecule of water. Due to kinetic energy, the particles that make up a liquid are in constant random motion, and so they will have a random arrangement. You might expect the particles at the surface at the macro level to form random surface as shown here. But what we should find out is how do intermolecular attraction influence the surface. First, let's look at intermolecular forces under the surface, where attractions of individual molecules pull on each other in all directions. At the surface, pull on the molecules is lateral and downward. There is negligible attractions above the molecules, and so the net force on the surface molecule is downward. The result of this downward force is that surface particles are pulled down until counterbalanced by the compression resistance of the liquid. Surface molecules are compressed more tightly together at the surface, forming a sort of skin on the surface, with less distance between them compared to the molecules below them, form a much smoother surface than one would expect from randomly moving molecules. What do you think surface tension will do to a liquid not confined in a container? In this model of a small water droplet, what is net direction with the force on the surface molecules? That's right, it is toward the center. And so a free-falling drop of a liquid takes on a spherical shape. Here we see water dripping from a faucet. If this not look familiar to you, turn on your faucet at home with a very little pressure and see what happens. Or do an internet search for the behavior of water and zero gravity to get a great view of a surface tension. Water in particular has a very high surface tension. Do you know the reason for this? What creates the attraction between water molecules? In looking at an individual water molecule, we can see the particularly strong attraction between the oxygen and hydrogen. Due to their opposite changes, hydrogen has a strong partial positive charge and oxygen a strong partial negative charge. This strong attraction occurs between many water molecules close by. The strong partial charge results in strong attraction between water molecule called hydrogen bonding. Interestingly, there are creatures that have evolved to take advantage of water's high surface tension. The water strider is a common insect that you may have encountered. What adaptation in their feet has occurred to take advantage of surface tension?